So can you see the Excel file here? I just shared it. Can you see it? Yes. So actually the column A data is the age. Okay. So let me just put the labels for the column is the age. And this one showing the average amount spent on the medical expenses. Okay, so average medical expenses. Okay. So in your lab assignment, the part A question, in your lab assignment, you have two variables. The first one is gas consumption and the second one is temperature. But we are having the different variables. But the method is exactly the same, okay? So in part A, what is the response variable? Okay, so we need to answer what is the response variable here? So age and average medical expenses. So what do you think is the response? Age or the medical expenses? So the response variable is dependent variable, okay, dependent. The response variable can be changed by the other variable, okay? So age, if age is dependent variable, age can be changed. Age is able to change it by the medical expenses. So do you think is it response variable?
I think it'd be the other way around because the medical expenses would be influenced by the age.
Yes, exactly. So medical expenses, actually it's the average medical expenses, but anyway, per month. But anyway, just put the medical expenses. So medical expenses is the response variable. Response variable is the dependent variable, and usually that's exactly what we want to know. Okay, the response variable, we are interested in more in response variable than the predictor, the explanatory variable, this age, independent variable. Okay, and part B is asking what is the predictor? So predictor here, so the other variable, that's the age. Okay, age. So predictor is also the explanatory variable and it's independent. Okay. And part C is asking perform a simple linear regression using Excel and put the output table from D1. So to conduct the simple linear regression, so go to click this data ribbon and there's a data analysis. So now we can click this data analysis and simple linear regression. Okay, so here, this one, regression. Click OK. And input Y ranges. So the Y for the dependent variable, that's the medical expenses, this one. So put the range. And at the bottom, put the ages. Okay, and we have the labels at the, well, in your file, there's no labels, but I put it. So click labels and output range. I'm gonna put this output table from D1. Okay, D1. And So I'm gonna put the line fit plots. So click OK. Okay, so that's, what is it? Okay. Literature output, but there's no line fit plots.
It's all the way on the right. You have to scroll over.
Oh, here. Okay, thank you. So this one is a line fit plot. Okay. Right. So, but I don't think we're gonna use that. That's not that much useful. So anyway, so we have the summary output. So this one, R square is coefficient determinant. Okay, that's the percentage of the Y values can be explained by this model. So it's a 5.57. So about 57.4% of the Y values, the medical expenses, can be explained by this model. So it's about 60%. So that's not that much enough. But anyway, and then this multiple R is the R score, the Pearson's R score. So it's a 0.7574, the linear relationship. The strength of the linear relationship is 0.7574. It's somewhat strong, okay? Because if it's the absolute value is close to 1, so no matter what the direction is, if it's negative, it's still the same. The strength getting greater if it's close to 1, a -1 or +1. So it's close to 1, okay? So it's, I think it's strong, somewhat strong, not very strong, but it's somewhat strong linear relationship. And here, this coefficient, this value is the intercept, y-intercept, and this one is the x-intercept. Y-intercept and coefficient for x. So that's the slope, okay? So this is a y value when x equals 0, and this is the slope, the change in y when the x value, age increase 1, okay? So that's the 16.89, that's the slope. So what is the question for part D? Write out the regression line function in the cell A15. It starts with y hat equals. So you can, that's for the part D, okay? Part C is this output y hat. You should put this hat because this model fitted just using the sample data, not the population data. So it's the sample regression line function. Okay, so y hat, and we put the y-intercept first. So -355.3 plus the x value 16.89. That's the coefficient, the number with x, okay, like this. So that's the regression function. Y hat is, so, or you can call it the regression model, okay? And part E, interpret the slope in context and put it in the cell A17. So before doing the interpret, let's do the same thing using the applet, okay? So because this is the lab assignment, but on the exam 3, there's some question asking you to do the simple linear regression using the applet. Okay, so but for this lab assignment, you have to put the Excel output. Okay, if you just did it, do it using the applet and just write the function without the Excel results, there's some deduction. So this is the applet you can use during the exam. So explanatory one, just put X, okay? X, that's the age, but just put X. And you can copy and paste from the column in Excel. Paste like this. And response, Y is the medical expenses. Like this, and just begin analysis, right? So here you have this model here, but it's just says Y because it doesn't know is it population data or sample data, but when you write the equation, you should put this Y hat, okay? So actually it's the same, but we're gonna use, I just put till the first decimal places. So we have exactly the same equation. Okay. And let's go back to the Excel, and what was the question for per E? Interpret the slope. Okay, let's interpret the slope. So the definition of the slope is the change in Y, okay, change, decrease or increase in Y of Y value per 1 unit increases in X. So in here, it should be, just let me write down the general definition first. So so it is changes, the changes in Y value per 1 unit increase in X value. So the change in Y. So Y value is medical expenses, okay? And the unit is dollars, okay? So the actually is the average medical expenses of a month, okay? So you can say instead of Y, you can put Y values, the average medical expenses per month. And it's negative 355.3, okay? Oh, I'm sorry. It's y-intercept. It's we're interpreting the slope. Slope is 16.89. Okay, so the change is increasing. Okay, it increases. So you can say the average medical expenses per month increases by 16 dollar by 16 and 89 cents, 16.89 per 1 unit increases in X value. So you can just put like about per 1 unit increases in X value, or you can say like this: when age increase 1 year. Okay. So that's the interpretation in context, interpretation for the slope in context. Okay, so that's the answer for part E. Okay, but your the context in the lab assignment, the data is different. Okay, so it's different, but it's the same way. Okay, and interpret.
So when it's like the positive plus 1689, for example, is that when we say it increases, but if it had a
Oh, I'm sorry.
minus sign?
It's decreases. I'm so sorry. That's a typo. Big it's really bad. I'm sorry. The average oh no. Oh no. I'm sorry. So we have plus sign here. Yeah. It's a positive,
Yes.
right? So if you have this positive slope increases. Okay. If you have negative slope, like if it's like negative here, let me put like if it's negative, you have to say decreases.
Okay.
But we have positive here, so it should be increases. Okay.
Okay. What does these minus sign in front of the y part mean?
This one, this the y-intercept. So I'm gonna answer that part right now. That's for
Okay.
that's for the part F. Okay. Part F is interpret the intercept in context and put it in the cell A19, but we'll put it A20, but it doesn't matter. Okay. So, or let me just change it to the 15 to A19. So that's for the F. Okay. So interpretation for the y-intercept. So y-intercept is the y value. So the general definition is the y value when x value is 0. Okay, that's the definition of the y value. Just put the context. So y value is the medical expenses. So here, this part, the average medical expenses per month, right? So the y value, the average medical expenses per month, that's a y value. Month is negative $355.3. Okay, so actually, so let's just leave it like this. And when x value is 0, when age is 0, okay, if your age is 0, yeah, it's kind of weird, but by the model, okay, just from the model, you can say if your age is 0, the medical expenses is negative. So expense is negative means you will get some money from the government or something, but actually for me, I'm not sure in the States, but I'm also the citizen of the South Korea. Okay, so when your babies are less than 1 year old, you will get some the voucher monies for the medical expenses. So I'm gonna get like $1,000 every month. Okay, so that's for beer. Okay, when you are in Korea and you are having a baby, the baby, you will get some voucher. Literally, it's some money. Okay, their account, under their account, you will get the $1,000 per month. Okay, so in that case, your medical expenses can be negative. You can just get $1,000, but you don't spend that much money for the baby's medical expenses. Then your medical expenses is negative. Okay, so I don't know why is the in this case, I don't know this data the in detail, but from this data anyway, the medical expenses is negative. So you will get some money, getting some money on average, negative $355.3 per month. if when your age is 0. Okay, so that's just the answer interpretation for this case. Okay, so did you get it?
Yes, thank you. That
Okay.
makes perfect sense.
Thank you. And per so the part G, interpret the R square in context and put it in the cell 21A21. So R square is the coefficient determination. Okay, so that's the percentage of the Y values can be explained by the model. Okay, so that's the R square, and in here, R square is here. So R square, it's 0.5736. And in the app, let me check the app. App says the R square is 0.5737. Okay, we have exactly the same value from the Excel, also from the applet. So that's per G. Okay, so the percentage of the Y values, so percentage of the medical expenses, average medical expenses. So 57.37% of the average medical expenses can be explained by the X value, by the AGs. Okay. By this model. Okay, by the model we get from the sample. Okay, so that's why we call the X value as the explanatory variable. Okay, so the Y values can be explained by the X values, and the percentage is this 57.37%. That's the R square. Okay. So just read this R square, and you have this R square as in decimal values, but change this in percentage. That's the percentage of the Y values can be explained by the X values by the model. Okay, by this simple linear regression model. Okay. And then the next question, we only have 2 more questions. So what is the correlation coefficient? It's the correlation coefficient. The coefficient determination is R square, and coefficient determinant is the R square, and correlation coefficient is the R score, Pearson's R. Okay, that's this one. This is multiple R. Or you can get this R. If you have this multiple R, you can calculate this R square. It's because this R square is just square of this R. So let me check this. If you square this value times this, see, this is the same, right? So this R, Pearson's R, correlation coefficient square is the R square, okay? So anyway, this R, and it gives us the strength and direction of the linear relationship between these 2 variables, okay? And the absolute value is 0.7574. It's the absolute value gives us the strength, okay? I would say if it's greater than 0.7, it's somewhat strong. If it's greater than 0.8, it's strong. And if it's greater than 0.9, it's very strong linear relationship, okay? But if it's like between 0.6 and 0.7, it's somewhat weak, okay? Weak relationship. But yeah, we have somewhat strong, okay? Somewhat strong linear relationship. And just multiple R, just absolute value. And the direction, you have to check this AG coefficients direction, okay, the slope. you need to check the slope. If slope is positive, then that's the same positive. I mean, the R scores, Pearson's R's, the sign, symbol is also positive. But if you have like here, negative here, but still, if it's negative, I'm sorry, you will have just the absolute value here. The multiple R just gives you the absolute value. Okay, so if you have negative slope, you have to put the negative before the Pearson's R square. Okay, so here the R square, R value is this one, 0.7574. Okay, 0.7574. Just put the fourth decimal place. That's the Pearson's R. And the sign should be the positive because our slope is positive. Okay, if your slope is negative, you have to put the negative here. But we have this positive slope, so it should be positive. The R should be the positive. And that's the H. And for the last, I. Last part. What is the predicted value for 40 degrees? Okay, so that's the, actually, this is 40 degrees. That's the question for the data in the lab assignment, but we don't have 40 degrees, but just think this as the age of 40. Okay, if age, do we have the age of 40 in our data? Yes, we have one. So let's switch, let's change this, not 40, so 30. Let's change the question. What is the predicted value for age of 30? What is the medical expenses, predicted medical expenses for the age of 30? Okay, then, so I changed the question for this sample. So you put the Y value, so let me, so here, I will say negative 355.3 plus 16.89 and multiply 30, age of 30, okay? So let me remove this I, okay. Then that's 151.4. That's the predicted value, predicted average medical expenses. For age of 30, okay? But in the level assignment 4, you have to calculate the Y value, predicted Y value for X value of 40, okay? So that's the answer. And let me, you can check your answer using this predicted value answer using this app. Okay, so let me share this. So here, when you scroll down at the bottom, there's a make a prediction. Okay, so if you put just the X value, 30, compute predicted value is 151.42. So yeah, we have 151.4. That's the same value. Okay, so just calculate it using the Excel because the purpose of the lab assignment 4 is you can get all the answers using the Excel. Okay, so please try to get the predicted value using Excel and check your answer using this make a prediction function in the applet. Okay, so but for the prediction part, you can use the applet on the exam 3. Okay,